Imagine for a moment, you're a mobile game developer. You've literally poured your heart and soul into creating this incredible new game.
Yeah.
It's got stunning graphics, addictive gameplay, a captivating story, everything. Players download it, they jump in, they play once, and then poof, they vanish.
Just gone.
Just like that. You watch your hard-won users disappear and you're left wondering, why? Why did they leave? And maybe even more critically, could I have seen this coming? Could I have stopped it?
Right. That's the core question.
That right there is the brutal reality of user churn, especially in, well, today's hyper-competitive digital landscape. So today, we're taking a deep dive into this fascinating world of how we can predict exactly who might churn before they even make that final exit. Our mission, really, is to explore a very specific and honestly pretty powerful process for using machine learning to tackle this exact challenge. We're drawing from a hands-on lab environment that shows just how these cutting-edge tools work in a practical setting.
A real-world kind of scenario.
It's about being truly proactive, not just reactive when it comes to keeping your audience engaged and, frankly, safeguarding your business.
Yeah, and what's truly fascinating here, I think, is not just the act of prediction itself, but the entire life cycle, the whole journey, really.
Life cycle, okay.
And involved in building, understanding, and then successfully deploying an AI model for a real-world business problem like customer retention in mobile gaming. We're going to meticulously trace that journey from the raw, sometimes messy data all the way to a fully operational deployed model. And as we go, we'll discuss the critical implications of each step.
Right.
This process fundamentally raises a really important question for any business leader, I think.
Yeah.
How can we leverage advanced analytics and machine learning to not just react to problems as they emerge, but genuinely anticipate and proactively solve them? How do we transform our whole operational strategy?
Exactly. That's the goal, isn't it? And the core of this deep dive, it comes from a very detailed guide on using Google Cloud's powerful platforms, specifically BigQuery ML and Vertex AI.
Right, the Google Cloud stack.
Our focus is squarely on predicting user churn in a mobile gaming app, and it leverages the rich behavioral data captured by Google Analytics 4, or GA4.
Which is huge these days, GA4.
Totally. So it's a comprehensive journey, really a blueprint, through setting up the necessary environment, training a sophisticated predictive model, understanding its intricate decisions, which, that alone is a huge leap forward in AI.
Oh, absolutely. The explainability part.
Yeah. And then finally, putting that intelligence into tangible action to make a real difference for, that hypothetical game developer we started with.
And it's vital to emphasize, I think, that the source material we're drawing from isn't just theory, right? It's not academic.
No abstract concepts here.
Exactly. It walks through a practical, step-by-step process. This is applied machine learning in action. We'll be looking at how robust cloud platforms like Google Cloud are engineered, really, to enable these complex ML workflows. From the very first stages of data exploration and prep, all the way through to generating real-time online predictions. It offers a clear, actionable pathway for anyone looking to implement AI solutions that deliver measurable business value in a real-world setting.
Okay, fantastic. So, with our mission clear, let's kick things off right at the very beginning. Let's talk about establishing the groundwork, the foundation for these machine learning endeavors. At the foundation, setting up the machine learning environment. So when you're looking to build something as complex as an AI model, maybe starting fresh in a cloud environment, where do you even begin? It can feel overwhelming, right?
Yeah, definitely.
I noticed our guide jumps right into something called Cloud Shell. What's the deal with that? What is Cloud Shell, and why is it the indispensable first stop for anyone navigating Google Cloud?
Right. Okay. Cloud Shell. Think of it as your portable, pre-configured data science workstation, but it's all accessible right from your web browser.
Okay, so no local setup needed.
Exactly. It's a virtual machine, but it comes preloaded with a whole suite of development tools, making it incredibly convenient. And crucially, it offers a persistent 5 GB home directory.
Persistent, so my stuff stays there.
Yep. Your files, your configurations, they stay put between sessions, which is super handy. And it runs natively on Google Cloud infrastructure, obviously. The real power, though, and why it matters so much, lies in its sheer convenience and the immediate productivity it offers. For anyone interacting with Google Cloud resources, it gives you direct command line access.
The command line? Okay. Like a terminal.
Just like a terminal. But here's the kicker. It does so with temporary credentials that are already pre-authenticated for you.
Ah, so no messing around with keys and logins every time.
Precisely. It completely eliminates that often tedious and, let's be honest, error-prone process of setting up your local machine with all the necessary SDKs, libraries, authentication mechanisms, all that
Oh,
stuff.
I've been there. Dependency hell.
Yeah, exactly. If you've ever spent hours wrestling with Python environments or dependency conflicts on your laptop, Cloud Shell is just a breath of fresh air. You open your browser, click a button, and bam, you're ready to start working with your cloud resources.
Nice.
For practical use, the core command line tool for Google Cloud, kuCloud, it comes pre-installed, and it even supports tab completion.
Oh, tab completion is life-saving.
It really is.
Oh.
It's a small thing, but mighty for productivity, helping you navigate commands and resources efficiently. You can immediately list your active accounts, your project IDs, confirm your connection and context within the cloud. It truly is the foundational step for any serious cloud-based development. It offers a powerful and, crucially, frictionless entry point. It lets you focus on the problem you're solving, not the environment you're solving it in.
Yeah, removes a big hurdle.
Definitely. Especially for maybe newer data scientists, it lets them focus on the actual science rather than getting bogged down in infrastructure setup.
That's a fantastic concept, a developer's dream, basically.
Mm-hmm.
No setup. So once we have that command line access sorted through Cloud Shell, the next crucial step outlined in our guide is creating something called a Vertex AI Workbench instance. This sounds like it's our actual dedicated workspace for the heavy lifting, the deep learning process itself.
Exactly.
So what is Vertex AI Workbench, and why is it the chosen environment for this kind of sophisticated machine learning task, especially for our churn prediction model?
Right. So Vertex AI Workbench is essentially your integrated development environment, your IDE, but specifically tailored for building and experimenting with machine learning models within the broader Vertex AI platform.
Okay, so it's part of Vertex AI.
Yep. And what's truly insightful here, I think, is how modern cloud platforms like this abstract away so much of the underlying complexity. You don't need to worry about provisioning servers in the same way.
Right.
Our source details that it comes with JupyterLab pre-installed and ready to go. JupyterLab is, hugely popular, kind of the standard interactive environment for data scientists.
I've definitely heard of Jupyter.
Yeah. And even more importantly, it's already configured with powerful GPU-enabled machine learning frameworks.
Ooh, GPUs. That's important for speed, right?
Hugely important. GPUs are often essential for accelerating the training of complex models, especially deep learning models, but even things like XGBoost can benefit. And setting them up manually can be a considerable hurdle, dealing with drivers and compatibility.
Yeah, no fun.
Vertex AI Workbench handles that. And the setup process, as described in our sources, it really highlights how user-friendly this is within the Google Cloud Console.
Yeah.
You just navigate through a few menus.
Yeah.
You might need to enable some recommended APIs just to make sure all the necessary services for your ML workflow are active.
Okay.
And then you simply click Create New Instance, give it a descriptive name like Lab Workbench, choose a suitable cloud region and zone, which is important, for data residency and performance, keeping compute close to data.
Right, latency matters.
Exactly. And while there are advanced options to customize the machine type, disk size, all that, the default setup is often more than sufficient to get started, even for pretty complex tasks. Then the instance takes a few minutes to spin up, and you get that satisfying little green check mark confirming it's ready.
The green check of success.
Always a good feeling. Once it's ready, you just click a button right next to the instance name, Open JupyterLab. That pops open a new browser tab, and instantly you're immersed in that interactive environment.
The notebook environment.
Yep, where you can write and execute code, explore large data sets, visualize your results, all that good stuff. But what's particularly powerful and really streamlines the workflow is that within JupyterLab, you can easily open a terminal window.
Ah, so you still have that command line access inside the notebook environment.
Exactly. This ability to run command line operations directly within your Workbench instance seamlessly connects the command line power we talked about with Cloud Shell to your interactive notebook environment.
That's really integrated.
It allows for a unified workflow. You can manage cloud resources, install packages, run scripts, and code your model, all within one integrated space. This setup significantly streamlines what we call MLOps, machine learning operation.
MLOps, right.
It reduces the friction between the development phase and the deployment phase. It's all about providing a dedicated, powerful, and comprehensive space for data scientists to rapidly iterate on their ML models without getting bogged down in environment configuration. It radically accelerates the path from an idea to a deployed solution.
That truly makes Vertex AI Workbench sound like the ultimate nerve center for ML development. It's fascinating how these platforms consolidate so much power, just stripping away those infrastructure headaches.
Yeah, it's a huge productivity boost.
Yes. So with this powerful hub ready, the next natural step in any project is getting your specific instructions, your blueprint right. Our guide talks about copying a notebook and configuring it. How do these notebooks fit into that picture? And what makes these files, these .ipnb files, so central to the entire machine learning process for data scientists today?
You're absolutely right. Notebooks are central. They're kind of the lingua franca for data science work these days.
Okay.
So the first step the guide outlines is copying the specific lab exercise notebook. Think of this notebook as a detailed, executable guide that combines code and explanation. It's not just code, it tells a story.
Like a recipe with instructions and ingredients.
Exactly like that. And you copy it from a cloud storage bucket, which is Google's object storage, using a straightforward command line transfer, like G-Cloud Storage Drop. This just shows how easily data and code artifacts are moved around and managed within the cloud environment. You're pulling that pre-written recipe from a shared pantry, basically. Once copied, you simply open the lab exercise.ipnb file within JupyterLab. Now, a crucial step here is connecting it to the right computational engine, or kernel, as they call it.
Kernel.
Yeah. Our guide details selecting a specific TensorFlow environment as the kernel. For anyone doing ML, you'll know the kernel is what actually executes the code you write in the notebook cells.
No, okay, it runs the code.
Exactly. It acts as the bridge, linking your Python code to the underlying machine learning framework, TensorFlow. In this case, making sure your commands are understood and run by the powerful hardware and software underneath. Then, the notebook usually requires you to define certain constants, like updating the cloud region variable.
Right, telling it where to run.
Precisely. This just emphasizes the need for environment-specific configurations to ensure your code executes in the right geographic cloud location, which can be important for latency, cost, and data residency rules. And finally, you execute each cell sequentially. You can click the little run icon or use a keyboard shortcut like Shift plus Enter. So why are notebooks like JupyterLab so prevalent and vital? Well, they're incredibly powerful because they combine live code, narrative text, mathematical equations, visualizations, and even the output, all in a single interactive document.
All in one place.
All in one place. This makes the entire workflow highly reproducible. Anyone should be able to run the same notebook and get the same results. And it's also incredibly explainable because you can intersperse your code with detailed explanations, observations, findings, maybe even failed experiments.
So it documents the process as you go.
Perfectly. It's also super easy to share with colleagues or just for documenting your experiments thoroughly. For prototyping, iterating on models, analyzing data, and documenting ML experiments, notebooks have really become the industry standard. For anyone looking to get hands-on with practical ML development, understanding the flow and utility of notebooks is absolutely key. They are, in a very real sense, the canvases on which data scientists paint their models, tell their data stories, and build their solutions.
That's a truly apt way to put it. The canvases on which data scientists paint their models. And what a setup it is. I mean, from a persistent virtual machine, robust command line access, to a full interactive workspace for coding and experimenting, we're now truly ready to dive into the core of the problem itself. 2. Building the brain. Training an XGBoost classifier for churn prediction. Okay, so our ultimate objective for this deep dive is predicting user churn on a mobile gaming application. We've all encountered apps we loved, then suddenly, for reasons we might not even fully articulate, we just stop using them.
Happens all the time.
But from a business perspective, why is predicting this churn so critically important, especially in that hyper-competitive, notoriously fickle mobile gaming space? What's genuinely at stake for these companies beyond just, losing one user?
Oh, it's huge. Predicting churn isn't just some technical exercise.
Yeah.
It has a direct and frankly profound impact on a business's fundamental viability and its growth strategy.
It's about the bottom line.
Absolutely. Churn directly impacts revenue, obviously. It impacts user base expansion, and it impacts the return on investment for all those expensive marketing campaigns they run to get users in the first place.
Right, acquisition costs.
Exactly. Think about it. Every user who leaves is a lost potential future purchase, lost engagement with the game itself, and a lost opportunity for valuable word-of-mouth marketing, which is gold in gaming.
True.
And here's the key thing. Preventing churn is almost always dramatically more cost-effective than acquiring new users. The stats vary, But acquiring new customers can be incredibly expensive, sometimes 5, 10, even 25 times more costly than retaining an existing one, depending on the industry.
Wow, that much.
Yeah, in mobile gaming where user attention is so fleeting and the competition is just fierce, retention really is the name of the game. And what's truly powerful about predicting churn, rather than just reacting after they've already left, is that it fundamentally allows businesses to be proactive.
Get ahead of the problem.
Precisely. Instead of waiting for users to abandon your game and then trying desperately to win them back, which, let's face it, is often difficult, expensive, and has a low success rate, they can implement targeted retention strategies before the user even considers churning.
Like what kind of strategies?
Well, could be personalized in-game offers, maybe targeted messages, highlighting features they haven't used, special events designed to re-engage specific user segments, or even tailored support messages if the data suggests they might be hitting a known pain point.
Oh, okay.
And the source specifies we're working with Google Analytics 4, GA4, data. GA4 is Google's latest analytics platform, and it's designed to give a more holistic, event-driven view of user behavior across websites and apps. It captures this rich tapestry of events and user properties.
So lots of detailed behavioral data.
Tons of it.
Mm.
And this comprehensive behavioral data makes it an ideal source for understanding those subtle signals of user engagement or disengagement.
Mm.
And by extension, predicting who might be on the verge of leaving your game. It helps you see those whispers of discontent before they become shouts.
Yeah, being proactive is definitely a game changer. But okay, before we can train any model, we need to prepare and understand our data. That's always step one.
Always. Garbage in, garbage out.
The source mentions exploring and preprocessing this GA4 data in BigQuery. For those who might not be familiar, what exactly is BigQuery and why is it the tool of choice for this initial crucial data work in an ML pipeline, especially when dealing with potentially massive amounts of user data?
Right. BigQuery. It's Google Cloud's fully managed, serverless, and highly scalable enterprise data warehouse. Its primary design goal is analyzing petabytes, literally petabytes of data at incredible speeds using standard SQL queries.
SQL, so analysts can use it easily.
Exactly. That's a huge plus. It makes it an absolute powerhouse for data work, particularly for the kinds of large-scale, event-driven data sets like those generated by GA4. Now, when it comes to machine learning, data preprocessing is, as you said, non-negotiable.
Got to clean the data.
Absolutely. While our source doesn't detail every single preprocessing step that would be a whole deep dive in itself, it implies the necessity. This usually involves cleaning the data, handling errors, outliers, dealing with missing values, and crucially transforming raw event logs into meaningful features. We call that feature engineering.
Feature engineering, like creating new data points from the raw stuff.
Precisely. For instance, transforming raw clickstream or event logs into user-level features like number of days since last login, average session duration, count of specific in-game actions, total purchases, things like that. Features the model can actually learn from. Now, the profound beauty of using BigQuery for this initial work is its seamless integration with BigQuery ML.
Okay, BigQuery ML. What's the ML part?
The ML part means it allows users to build and execute machine learning models directly within BigQuery using standard SQL queries.
Wait, you train the model using SQL? Inside the data warehouse?
Exactly. This is a massive efficiency gain. It fundamentally eliminates the need to move vast amounts of data to separate ML environments or tools.
Wow, okay. That saves a lot of hassle.
Immense amounts. You're analyzing, preparing, and even training your model right where your data already lives. This saves huge amounts of time, reduces complexity, minimizes data transfer costs, which can be significant, and it simplifies data governance because the data isn't leaving its secure environment.
So bring the compute to the data.
That's the paradigm. It's fundamental to creating efficient and scalable ML pipelines, especially when dealing with the colossal volumes of user behavior data that GA4 can generate. And you asked earlier about scalability, even for a smaller game, maybe millions of users, not billions. BigQuery's serverless nature makes it cost-effective. You only pay for the queries you run. You don't provision servers. So it scales down nicely too, while still giving you enterprise power.
That sounds incredibly efficient training models right where your data lives using SQL and scalable both up and down. Fantastic. Okay, so our source specifies training a BigQuery ML XGBoost classifier for this churn prediction. For those of us maybe not deep in the algorithm weeds, what exactly is XGBoost and what makes it such a popular and powerful choice for classification tasks like predicting churn? Why not, say, a deep neural network that we hear so much about?
Right, XGBoost. It stands for Extreme Gradient Boosting. At its core, it's a very powerful, highly efficient, and flexible open source library that implements something called gradient boosted decision trees.
Okay, gradient boosted decision trees. Break that down a bit.
Sure. Imagine you build a relatively simple learning model, usually a decision tree, to try and predict churn based on the features. It'll make some mistakes. Then you build another tree, but this second tree doesn't just learn from the data. It specifically focuses on correcting the errors made by the first tree.
Ah, so it learns from the mistakes.
Exactly. Then you build a third tree that corrects the combined errors of the first two, and so on. You build a whole sequence, an ensemble of these trees. Each new tree is an expert trying to fix the shortcomings of the team that came before it. Collectively, they become incredibly precise and robust.
Like a team of specialists getting better and better.
That's a great analogy. It's a boosting technique, specifically using gradients to figure out how to correct those errors most effectively. The extreme part just refers to the specific optimizations that make XGBoost particularly fast and scalable. For our churn prediction, which is a binary classification task, churn or not churn, XGBoost is exceptionally well suited. There are several key reasons it's so favored and often wins data science competitions. First, performance. It's renowned for its incredible speed and accuracy on structured, tabular data like we get from GA4.
Fast and accurate, good combo.
Definitely. Second, robustness. It handles various data types well and can manage missing values gracefully, which is super important because real-world data is rarely perfect. Third, scalability. It's optimized for large data sets, aligning perfectly with BigQuery's capabilities. You can throw a lot of data at it. Now, regarding your question about deep neural networks, deep learning is amazing for things like image recognition, natural language processing, complex patterns, and unstructured data. But for structured, tabular data problems like churn prediction, XGBoost often provides comparable or even superior performance.
Really? Better than deep learning sometimes.
Often, yes, for this type of data, and usually with less computational expense, less complex tuning, and crucially, often a greater degree of inherent interpretability, although it's still complex. Deep learning models can be much more of a black box.
Right, harder to explain.
Exactly. And the fact that the training happens within BigQuery, using standard SQL, that BigQuery ML integration, that further cements XGBoost's popularity here. This SQL-first approach democratizes machine learning. It allows data analysts already skilled in SQL to build sophisticated models without needing to become deep Python programmers or ML framework experts overnight. It empowers a wider range of people.
That makes perfect sense. It's about using the right tool for the job, optimizing for this specific type of data, and making it accessible. But training a model isn't always a one-and-done deal, is it? Sounds like there's more to it than just hitting train.
Oh, definitely not one and done.
Our source mentions tuning the XGBoost classifier using BigQuery ML's hyperparameter tuning features. Okay, hyperparameters. What exactly are those, and why is tuning them so crucial for getting the best performance out of our model and avoiding common pitfalls like underfitting or overfitting?
You're absolutely right. Tuning is critical. It's rarely a one-shot process. So to understand hyperparameters, let's quickly contrast them with model parameters.
Okay, parameters versus hyperparameters.
Right. Models learn internal parameters during the training process itself. Think of these as the coefficients in a linear regression or the weights in a neural network. The model figures these out from the data. Hyperparameters, on the other hand, are the settings that we, the data scientists or engineers, define before the training process even begins. They control the learning process itself.
Ah, so they're like settings on the training machine.
That's the decent way to think about it. For an XGBoost model, hyperparameters might include things like the learning grade, which controls how much each new tree contributes to the final prediction too high, and it might overshoot too low and it learns too slowly. Or the max depth of each decision tree, which limits how complex individual trees can get. Or the nestimators, which is the number of trees in the sequence. Why is tuning them so crucial? Because poorly chosen hyperparameters can drastically hurt your model's performance. If your hyperparameters lead to a model that's too simple, maybe the trees are too shallow, or you don't have enough trees, it might underfit the data.
Underfit, meaning it doesn't learn well enough.
Exactly. It fails to capture the underlying patterns in the training data, so it won't perform well on new, unseen data either. It's like trying to draw a complex picture with only a thick crayon. You miss the details.
Got it.
Conversely, if your hyperparameters create a model that's too complex, maybe the trees are incredibly deep, learning every little quirk, it might overfit the data.
Overfit, meaning it learns too well.
Kind of. It essentially memorizes the noise and peculiarities of the training data, rather than learning the generalizable patterns. So it performs brilliantly on the data it was trained on, but poorly on new data it hasn't seen before. It's like a student who memorizes the answers to last year's test, but doesn't actually understand the subject.
Okay, so tuning is finding that sweet spot.
Precisely. Tuning is the methodical process of searching for the combination of hyperparameter settings that allows the model to learn the underlying patterns effectively and generalize best to new data, striking that optimal balance between simplicity and complexity. And the fact that BigQuery ML provides built-in hyperparameter tuning features is a massive advantage. This automates what can otherwise be a very tedious, iterative, and computationally expensive process.
How does it automate it?
Instead of you manually trying out dozens or hundreds of different combinations, let's try this learning rate with that max depth. BigQuery ML can intelligently search through a range of hyperparameter values you define, using smart algorithms to efficiently find the optimal or near optimal set based on a chosen evaluation metric.
Wow, so it does the trial and error for you.
Exactly. It significantly simplifies the workflow. It's like having an automated assistant try hundreds of recipe variations at lightning speed until they find the perfect one. This automation frees up data scientists to focus on higher-level thinking, like better feature engineering or understanding the business problem, rather than just brute force experimentation.
That oven analogy you used earlier really baked the point, and this automated tuning sounds like a huge time saver. Okay, so we've gone through all this effort prepping the data, training our XGBoost model, carefully fine-tuning its settings to avoid underfitting or overfitting. But how do we actually know if our classifier is any good at predicting churn? The source highlights evaluating its performance. What kind of metrics are typically used to measure a model's success, and what does good performance actually look like in this context of predicting user churn, where, as we said, the stakes are pretty high for a mobile game developer?
That is absolutely the critical question after all that work. How do we quantify good? Did it actually work? While our source doesn't list the specific metrics used in that particular lab, for a binary classification task, like churn prediction, a user either churns positive class or they don't. Negative class. There are several standard metrics we almost always rely on. The most common one, the one people often think of first, is accuracy. It's simple. What percentage of predictions did the model get right overall?
Okay, overall correctness. Seems straightforward.
It seems straightforward, but accuracy can be really misleading, especially if your classes are imbalanced.
Imbalanced.
Meaning one class happens much more often than the other.
Yeah.
In churn prediction, usually most users don't churn, right? Maybe only 5% or 10% churn in a given period.
Yeah, hopefully.
Right. So imagine only 5% churn. A really dumb model that just predicts no churn for everyone would still achieve 95% accuracy.
Wow, okay, I see the problem. 95% accurate, but useless.
Totally useless for finding the churners, which is our actual goal.
Yeah.
So we need more nuanced metrics. We look at precision. Precision asks, of all the users the model predicted would churn, how many actually did churn? High precision means when the model says someone will churn, it's usually right. This is important if the cost of a false positive is high.
False positive, meaning predicting churn when they won't.
Exactly. If falsely flagging a user means you spend money on an unnecessary retention campaign, or worse, annoy an engaged user with an irrelevant "please don't leave" offer, you want high precision.
Okay, precision is about being right when you predict churn. What else?
Then there's recall, sometimes called sensitivity. Recall asks the opposite question. Of all the users who actually did churn, how many did our model correctly identify? High recall means the model is good at finding most of the churners.
Ah, so recall is about not missing the ones who are really leaving.
Precisely. This is crucial if the cost of a false negative is high. A false negative is missing a user who will churn. If every churner represents significant lost revenue, maybe they were a big spender, you want to maximize recall to catch as many of them as possible, even if it means you get a few more false positives along the way. Often there's a trade-off between precision and recall. Tuning the model might increase one but decrease the other. So we often look at the F1 score. The F1 score is the harmonic mean of precision and recall, providing a single metric that tries to balance both.
Okay, F1 is a balance.
Yep. And then there's another really important one, AUC-ROC. That stands for Area Under the Receiver Operating Characteristic Curve. Sounds complicated.
It does sound complicated.
Yeah. But basically, it measures the model's overall ability to distinguish between the two classes, churn versus no churn, across all possible decision thresholds.
Yeah.
A higher AUC-ROC score, closer to 1, indicates a better overall ability to differentiate between users who will churn and those who won't. It gives a good general sense of the model's discriminative power. Now, what constitutes good performance, it really depends entirely on the specific business objective and the relative costs of those different types of errors,
Mhm.
the false positives versus the false negatives.
So the business has to decide what's more important.
Absolutely. For churn prediction in a mobile game, maybe missing a churner, a false negative, is considered much more detrimental than incorrectly flagging a non-churner, a false positive. If missing a churner means losing a high-value player, you might heavily prioritize maximizing recall, even if it means your precision drops a bit and you send retention offers to a few people who weren't going to leave anyway. Conversely, if oversending retention offers is known to annoy players and maybe even cause churn, you might prioritize precision more heavily. It's always a critical balance driven by business strategy, costs, and goals. And crucially, evaluation isn't the final step. It's often an iterative process. The results feed back into maybe tweaking features, trying different hyperparameters, or even rethinking the model approach to continuously improve performance against those business goals. It's a cycle.
It's really fascinating how those metrics aren't just abstract numbers, but directly translate into concrete business impact and strategic decisions about risk and reward. But okay, even with the best metrics showing the model is accurate or has high recall or whatever, there's still that nagging why. We've got this accurate model, maybe XGBoost, but what's going on inside it? How did it reach that conclusion? And that, I think, brings us to what might be the most compelling part of this entire journey, the explainability. 3, understanding the brain. Explaining the model's decisions. Okay, this is where it gets really interesting for me. We have this powerful XGBoost model. It can predict churn with high accuracy, high recall, whatever we tuned it for. But often with these complex models, it can feel a bit like a black box, right?
Definitely the classic problem.
You feed it data, it spits out a prediction, this user will churn or this user won't. But the reasoning, the why, remains a mystery. The source explicitly mentions explaining the XGBoost model with BigQuery ML Explainable AI global feature attributions. So what exactly is explainable AI, often called XAI, and why is it becoming so vital in today's world of advanced AI? Why can't we just trust the accurate prediction if the metrics look good?
You've hit on one of the most critical challenges and frankly one of the most exciting areas of progress in modern AI, that black box problem. Many advanced machine learning models, particularly things like deep neural networks, but also complex ensemble models like our XGBoost here, can achieve incredibly high accuracy, but their internal decision-making processes are often opaque. Very cumbersome.
Hard to follow the logic.
Extremely hard, sometimes impossible for a human. It's difficult to understand why they arrive at a particular prediction for a specific user or scenario. And this lack of transparency is a significant barrier, especially when these models are deployed in high-stakes applications. Think finance loan applications, fraud detection, think healthcare diagnostic aids, or in our case, predicting critical business outcomes like customer churn that directly impact revenue and strategy. This is precisely where explainable AI, or XAI, steps in. XAI is really an umbrella term for a set of techniques and methodologies specifically designed to make AI decisions understandable to humans.
Making the black box less black.
Exactly. Or maybe making it a glass box. It's not just about what the model predicts, but providing insights into why it made that prediction. What specific factors or features did it consider most important? How did those factors influence the final outcome? Imagine being able to peek inside that box and see the logical pathways, or at least get a reliable summary of them. Why is it becoming so vital? There are multiple really compelling reasons. First, as you hinted, trust and transparency. For AI to be widely adopted and accepted, especially in regulated industries, or for applications that directly impact people's lives, users and stakeholders need to trust it. Transparency builds that trust. And in some sectors, explainability is becoming essential for regulatory compliance. Adhering to ethical AI principles, you need to be able to explain decisions if challenged.
Right, you need accountability.
Absolutely. Second, and this is crucial for the people building these models, it's invaluable for debugging and improvement. If your model is making errors, maybe showing bias, understanding which features it's misinterpreting, which data points are causing issues, if there's a hidden bias in the training data it picked up on, allows developers to diagnose problems and iteratively improve the model far more efficiently. You can fix the root cause, not just fiddle with settings hoping it gets better. And third, and this is where it gets really powerful for businesses like our game developer, XAI provides crucial, actionable business insights. Knowing why users churn is often far more valuable than just knowing who will churn.
The why is the actionable part.
Exactly. If your XAI tells you that a significant driver of churn is, say, users getting stuck on level 5, or a sudden drop in engagement after a poorly received game update, or maybe a lack of interaction with social features. That's not just a prediction, that's actionable intelligence.
So you can fix level 5 or roll back the update or promote social features.
Precisely. You can then design targeted interventions, update game mechanics, improve onboarding, reevaluate the game's economy, address those root causes identified by the AI. Connecting this to the bigger picture, XAI transforms that raw predictive power into strategic insight. It allows for precise, impactful business interventions that go way beyond just sending a generic, "we miss you" email. It empowers decision makers with the why, enabling them to optimize their product, their marketing, their whole strategy, moving from reactive firefighting to proactive shaping of the user experience.
That's incredibly powerful, truly turning a prediction into a strategic lever you can pull. Now, the source specifically mentioned global feature attribution. So what does global mean in this context of explainability, and what kind of specific insights do these global attributions provide that are so valuable for our churn prediction model? How do they help our game developer understand the big picture of why users leave?
Right. Global versus local is a key distinction in explainability. Our source focuses on global feature attributions. What global means here is that these attributions provide an overview, a summary, of which features are generally most important across the entire data set for the model's predictions overall.
So not for one specific user, but for everyone on average.
Exactly. It gives you that broad understanding of the model's general behavior and the main drivers of churn within your entire user base. It's about seeing the forest, understanding the dominant forces at play for your typical user, rather than dissecting the reasons for one specific prediction about one individual tree, which would be a local explanation.
Okay, global is the big picture view.
Yep. To conceptualize how it works, various techniques often underlie these explainable AI features in platforms like BigQuery ML. Common methods you might hear about are SHAP, that's Shapley Additive Explanations, or maybe LIME, though our source doesn't name them. These are the kinds of concepts involved. They essentially work by assigning an attribution score or an importance value to each input feature for the model.
A score for each feature, like days since login or total purchases.
Exactly. These scores indicate how much, on average, each feature contributes to the model's output, pushing the prediction towards churn, or towards not churn. A higher absolute attribution score for a feature means it plays a more significant role in the model's decisions across all predictions. It reveals its general influence. So for our churn prediction model, global feature attributions would provide invaluable high-level insights. For example, the model might reveal that across the entire user base, number of days since last login is by far the strongest indicator of churn. Its global attribution score is the highest.
Okay, inactivity is the biggest predictor overall.
Right. That tells the game developer. Pay close attention to users who become inactive. That's your biggest general red flag. Or perhaps total in-game purchases consistently shows up as a feature with a high negative attribution score.
Meaning it prevents churn.
Exactly. It strongly pushes the prediction towards not churn. This tells the developer that highly engaged players who spend money are significantly less likely to leave. That might inform strategies to foster more opportunities for meaningful microtransactions or add loyalty rewards for those high-value players. Other insights might reveal the global importance of number of sessions per week, completion rate of tutorial levels, or even engagement with specific in-game events or social features. This information is incredibly actionable for businesses because it directs their strategic efforts at a high level. If you know globally that days since last login is a major churn predictor, you can implement system-wide proactive measures for users hitting a certain inactivity threshold, maybe automated push notifications, special welcome-back offers, or personalized quests triggered after, say, 3 days of inactivity.
So it guides broad strategy based on the biggest levers.
Precisely. If you find that, globally, users who complete the tutorial are far less likely to churn, you might invest development resources in improving that tutorial experience for everyone, making it more engaging or rewarding. It directly informs business strategy by highlighting the most impactful levers identified by the AI across the board. It transforms that potentially complex model's aggregate knowledge into clear strategic priorities, helping keep more players engaged overall.
That's the true beauty of it, moving from that potentially murky prediction to clear, actionable intelligence at a strategic level. It's like the model is saying, hey, focus your efforts here. This is generally why people are leaving. Brilliant. So with all that insight, the next natural step is to really put this well-understood brain to work in the real world. 4, putting the brain to work. prediction and deployment. Okay, so we've trained our model, we've used explainable AI to understand its decisions, we know why it thinks users churn in general. Now we need to actually use it to make predictions. The next step the source outlines is generating batch predictions. What exactly does batch prediction mean in the context of machine learning, and when would a company, like our mobile game developer, typically use this method compared to, say, getting predictions instantly for one user at a time?
Right, batch predictions, pretty much exactly what it sounds like.
Yeah.
You apply your trained machine learning model to a large data set, a big batch of new unseen data all at once to generate predictions for all of them.
So processing many users simultaneously.
Exactly. Instead of making predictions one by one in real time as events happen, you process a large collection of inputs together, maybe overnight or once a week, and then you collect all the prediction results. Think of it like processing a massive company payroll at the end of the month, rather than calculating each employee's pay the second they clock out.
Okay, periodic, large-scale processing.
That's the idea. For our mobile game developer, this method has several really critical use cases. They might use it to generate daily or weekly reports. For instance, at the end of each day, they could run a batch prediction job on all their active users to identify everyone who is currently flagged as high risk of churning.
So they get a daily list of at-risk players.
Yep. This allows them to monitor the overall churn risk trend in their user base, see how effective their general retention efforts are, maybe track it week over week, and plan resource allocation accordingly. Another really common use case is for campaign targeting.
Ah, sending out offers.
Right. Let's say they want to launch a targeted retention campaign, maybe a special discount on in-game currency or a unique item for returning players. They can use batch prediction to efficiently identify a specific segment of users, say everyone with a churn probability between 60% and 80% who hasn't logged in for 5 days, and then exclusively target those users with the campaign. This maximizes the campaign's efficiency and ROI, rather than spamming everyone.
Smart targeting.
Definitely. It's also super useful for offline analysis, maybe generating predictions on historical data to understand past churn trends, or to test how the model performs on different user segments before deploying it live. And the efficiency of BigQuery ML, which we talked about earlier, truly shines here again. Because it's designed for large-scale data processing, you can run these batch predictions on vast amounts of data, potentially the entire user base,
Right.
millions of records directly within the data warehouse itself. You leverage BigQuery's immense scalability without needing to extract the data or manage a separate large-scale processing cluster.
So perfect for those big scheduled jobs.
Exactly. It's ideal for scenarios where you need predictions for a large group of users at a defined interval, maybe daily or weekly, rather than needing an immediate sub-second response for a single user interaction. It's about efficiently processing information for strategic overview and large-scale planned actions.
Okay, that makes sense. Batch predictions are great for those large periodic reports and targeted campaigns where timeliness is important, but not necessarily instantaneous. But then once we have our model and we can make these batch predictions directly in BigQuery, why would we then need to take the extra step of exporting the model file itself to Google Cloud Storage or GCS? What's the purpose of this step? It seems a bit redundant if BigQuery ML can already do so much with the model.
Yeah, that's a great question, and it really highlights a critical piece of the puzzle. When you move from just training a model to actually operationalizing it in different ways, it's about flexibility and integration. So while BigQuery ML is incredibly powerful for training models and generating those batch predictions within the data warehouse environment, many real-world applications require the model to be accessible outside of BigQuery, particularly for what we call online or real-time predictions.
Real time. Okay, the instant prediction.
Exactly, the ones that demand an immediate response, maybe in milliseconds. And BigQuery ML itself isn't really designed to be that ultra-low latency, high-throughput serving layer for live applications. So Google Cloud Storage, GCS, acts as this highly scalable, durable, and globally accessible object storage service. Think of it as a central, universal, infinitely expandable warehouse in the cloud for all sorts of files.
Like a giant hard drive in the cloud?
Sort of, yeah, but much more scalable and reliable. It's the perfect place to store various artifacts produced throughout your ML workflow data sets, configurations, evaluation results, and most critically here, your actual trained machine learning models once they're ready.
So you save the finished model file to GCS.
Precisely. The reason you export your model from BigQuery ML, where it was trained, to GCS, is fundamentally to make it available for other services and applications that are designed for that real-time serving. GCS acts as the bridge, Let's use that engine analogy again. You've engineered your perfect high-performance engine on the factory floor that your model trained in BigQuery ML. While you can test it extensively there, batch predictions, to actually put it into a production car that needs to drive on the highway in real-time traffic, you need to move that engine to a universal parts warehouse. It's GCS.
Ah, so other systems can pick it up from the warehouse.
Exactly. From GCS, other specialized services like Vertex AI Prediction, which we'll get to next, can easily pick up that standardized model file and load it for efficient real-time inference. Or maybe other custom applications need to download the model file to run it in a different environment. GCS provides that accessible, structured, and highly available storage layer for your model artifact. It decouples the model training environment from the model serving environment, which is absolutely crucial for building robust, flexible, and scalable MLOs pipelines. It's a standard best practice in modern machine learning infrastructure to separate these concerns.
Okay, that makes the separation of concerns very clear. The warehouse analogy really helps picture it. GCS holds the finished parts ready for use anywhere, so storing our model in GCS makes it accessible for a wider range of uses, especially real-time ones. And that brings us to the grand finale where the rubber truly meets the road. The final objective outlined in this deep dive is to upload and deploy our exported XGBoost model to a Vertex AI Prediction Endpoint for online predictions. What's the fundamental difference between an online prediction and the batch prediction we just discussed? And what specifically does this prediction endpoint allow us to do that's so impactful, maybe even transformative, for a business like our mobile game developer?
Right, this is where the magic really happens in terms of immediate interactive value.
Yeah.
This is enabling instant personalized action based on the AI. As you said, we've covered batch predictions, processing large data sets all at once, often for reports or scheduled campaigns. Online predictions, in sharp contrast, are all about real-time, very low latency predictions.
Low latency, meaning super fast.
Exactly. Made one by one, or maybe in very small batches, typically in direct response to a live user action or some critical system event happening right now. The key here is immediacy and responsiveness. Milliseconds matter. Let's consider our mobile game developer again. An online prediction scenario might look like this. A user completes a particularly challenging level known to be a point where some players drop off. Or maybe they log in after a week of unusual inactivity. Or perhaps they make their third in-app purchase within 24 hours.
So triggered by specific user action?
Exactly. In that exact moment, the game's backend system could fire off a request to the deployed model. Hey, prediction endpoint. For this specific user, user ID 12345, given their current activity and recent behavior profile, what's their likelihood of churning in the next 7 days? The model, hosted on the endpoint, processes this single request instantly and sends back a prediction, say 75% likelihood of churn, probably within 50 milliseconds.
Wow, that fast.
Ideally, yes. That's the goal of online prediction systems. Now, the Vertex AI Prediction Endpoint is the managed service from Google Cloud that actually hosts your deployed model, which it loaded from GCS, and makes these real-time predictions possible at scale. Think of it as a dedicated, highly available, and automatically scalable server specifically for your AI model, just sitting there, optimized, waiting for prediction requests.
So it's the live server for the model.
Precisely. It provides a stable API endpoint, basically a unique, persistent URL, that any authorized application, like your game's backend, a website personalization engine, maybe a fraud detection system, can call programmatically to get predictions instantaneously. Key capabilities include automatic scaling, handle sudden spikes in traffic without you worrying about servers.
So if lots of users log in at once, it scales up.
Yep, automatically. It ensures incredibly high availability, so your game isn't trying to call a prediction service that's down. And it even handles robust versioning, so you can deploy new, improved versions of your model seamlessly, maybe directing a small percentage of traffic to it first, and easily roll back if needed, all without disrupting the service. And the why of this final step, why go through all this? It's monumental because it completes the full machine learning lifecycle, from raw data to real-time action. It takes the deep insights derived from your data, captured by your meticulously trained and explained model, and makes them actionable in real time, right at the point of user interaction.
Lies in the loop.
Absolutely. This transforms a theoretical model stored in a file into a continuously running, intelligent decision-making engine embedded within a business's live operations. For the game developer, it means they can trigger an immediate, personalized in-app message. Hey, stuck on level 5, here's a free hint. Or maybe a special offer. Welcome back, here's 100 free coins. Or even flag a high-value, high-churn risk user for a human customer support agent to reach out to. The second that user's behavior triggers a high-churn prediction.
Instant personalized intervention.
Exactly. This allows for incredibly proactive micro-interventions that can significantly improve user retention, personalize the player experience dynamically, and ultimately safeguard and boost the game's revenue. So where all that data exploration, model training, and explainability truly translate into tangible, immediate business value. It moves you from insights derived yesterday to intelligent action taken right now. It enables a level of dynamic responsiveness that was previously impossible, fundamentally changing how businesses can interact with and retain their customers.
Wow, what a journey we've taken. Seriously. We started with just raw Google Analytics 4 data, maybe those event logs, and meticulously walked through the entire process, building a powerful XGBoost model in BigQuery ML, training it right there with SQL,
Where the data lives?
then tuning it carefully using automated tools, all the way to deployment for these super fast, real-time churn predictions on a Vertex AI endpoint. We explored how BigQuery lets you work directly and efficiently with potentially massive data sets.
Without moving data around unnecessarily.
The absolute importance of hyperparameter tuning for getting optimal performance, avoiding those underfitting, overfitting traps, and then how the magic, really, of explainable AI lifts the lid on the why behind the model's decisions, giving us actual actionable insights, not just a raw prediction score.
Yeah, and if we connect this to the bigger picture, step back for a second. What we've really witnessed here is a complete enterprise-grade machine learning workflow in action. This deep dive wasn't just about specific tools like BigQuery or Vertex AI, or even just about churn prediction, really. It was about the principles of modern MLOps machine learning operations.
The whole process, end to end.
Exactly. Efficient data handling at scale, robust model training, and continuous optimization, ensuring model interpretability for trust and getting those actionable insights, and then seamless deployment for whatever kind of predictions you need, whether it's those periodic batch processes for reports and campaigns, or critical real-time online applications driving immediate actions. This entire structured approach, this methodology, it raises a really important question, doesn't it? How remarkably adaptable are these same principles, this way of thinking, to other critical business challenges far beyond just predicting user churn in a game?
Right. The pattern applies elsewhere.
The underlying methodology, the systematic way of tackling a problem with data and AI, it applies to so much more.
Precisely. So, thinking about that, what does this all mean for you, our listener? When you consider the power of predicting something like user churn with this level of detail and explainability, it's obviously huge for a mobile game, but think bigger.
Yeah, extrapolate.
If we can predict when a user might leave a gaming app based on subtle behavioral signals, what other areas in business or even in our daily lives could profoundly benefit from similar proactive predictions? I mean, you could imagine predicting equipment failure in manufacturing before a costly assembly line goes down.
Predictive maintenance, yeah, huge area.
To personalized interventions in healthcare, maybe identifying patients at risk of complications before they happen, or optimizing traffic flow in smart city planning to prevent gridlock before it starts. This kind of predictive capability, especially when you can understand the why, truly shifts the paradigm across so many industries. So the question for you is, what stands out to you as the most impactful implication of this kind of predictive power in your own world or your own industry?
Exactly. And that capability to not just predict what is happening, but to truly understand why it's happening. That piece, powered by explainable AI, that's what fundamentally shifts the paradigm. It moves us from reactive problem solving, cleaning up messes after they happen, to proactive intervention and genuine strategic advantage. The real frontier in AI, I believe, isn't just building models that are incrementally more accurate. It's ensuring they are transparent, trustworthy, and crucially actionable.
Making them useful and reliable.
Precisely. The seamless integration we saw here, massive data processing in BigQuery, powerful and understandable models like XGBoost with XAI, and accessible deployment tools like Vertex AI Prediction Endpoints. This signifies a new era of truly data-driven, proactive decision-making. This deep dive should really leave you pondering. How will this kind of proactive intelligence, this ability to anticipate and understand, reshape the way we all approach challenges and opportunities in the coming years?